Hey guys, this is Patrick from STH, and this is my third annual talk at Netrio Nugget 2022. And if you've seen my talks for the last 2 years, we've explored some of the really cool things happening in the server and data center hardware industry, and that is exactly what we are going to cover again today. Now, if you don't know me, my name is Patrick Kennedy. I founded ServeTheHome in 2009. Ever since then, we have been expanding and we now cover all the server storage and networking reviews. We really do like the hands-on reviews for the industry, and we get really into the details. We get to benchmark stuff and have just a ton of fun with the hardware. ServeTheHome at this point reaches millions of readers every single month, and our coverage on STH reaches all the way from the data center out to the edge devices and even things that you can have in your own home lab. We now have millions of people coming to the ServeTheHome main site every single month, and we've even been growing. Our new thing this year is we've been growing our YouTube channel, and we should hit about 100,000 subscribers at the end of this month. So my one ask, of course, is going to be, if you do want to subscribe to ServeTheHome Video, feel free to. We're trying to hit that 100,000 by the end of the month, so we'll see how that goes. Now, something I did last year that I think is actually pretty valuable is looking at what we talked about the previous year and seeing if what I said came true or if I was full of malarkey. And so here's a slide of what we went over last year. And I think the chip shortage has still been a story, especially if you tried to ordering network switches. A lot of times you're seeing lead times of, a year or more. So that is certainly still the case. And in terms of 2022 to 2025, really changing hardware, I think we're at the cusp of that. And so today's talk is going to be really focused on what's going to happen in the next 18 months or so, what you need to prepare for. But I think a lot of the trends that we talked about last year are certainly relevant today. For example, we are definitely seeing power and cooling requirements go up a lot. We'll talk a little bit about that in a little bit. The rise of interconnects, definitely seeing a lot of movement on interconnects, way more than we've seen previously. Definitely have some crazy chips and wild security going on. And over the last year, I definitely think that with the 5G rollouts, we have seen a lot more focus in the industry on what to do at the edge and how to deal with edge computing. Because, for a long time, everything had been like, how do we go put things in the cloud? And now it's, well, how do we either extend the cloud or build out things at the edge, whether that's AI applications for video inferencing and stuff like that, doing video analytics, or if it's just kind of providing services or gaming services or whatever it is at the edge. Those tend to be very big topics today. And so I think we have a pretty darn high success rate. And so let's get into this year's topics. Okay, so talking about the next 18 months, we can't really talk about all of the things on the roadmap, but we can talk about some of the next things in terms of the very big CPUs that are coming. If you don't keep up with the hardware industry, I think some of this stuff is going to absolutely shock you. But because we're going to get bigger CPUs and GPUs and all kinds of accelerators, that also means that we are going to need more power and cooling. We'll talk a little bit about that and some of the exotic things that are really starting to happen. Now, if you happen to work with VMware, you probably saw vSphere 8 launch just recently at the latest VMware Explore. And one of the big key topics there was DPUs. And you may not know what a DPU is, but this is one of them right here. And we're going to talk about why these DPUs are these new classes of network devices that are going to be absolutely huge this year. We're going to talk a little bit about what's happening with CXL, because Compute Express Link is a huge topic in the industry right now. And then finally, we're going to talk about this new chiplet approach and why we're going to have more customization and more fragmentation in the market because of the chiplet approach. That's a lot of topics, so let's get to it. Okay, so the first one I want to talk about is just how big these CPUs are getting. If you have a just mainstream 2-socket server, we're not looking at 4-socket CPUs, which tended to be a little bit different in terms of core counts, but we just kind of went and said, okay, let me go look at all the 2-socket, mainstream 2-socket CPU cores, per socket from 2010 all the way through 2022. Now, the early period where you had, say 2010 to 2012, that's really where Intel, had an awesome product generation, and really, AMD struggled. And one of the big things that you saw in that generation is that AMD, even though they had more cores, they were not as powerful cores. So Intel actually took the lead at that point. But what you were basically looking at, and Intel definitely took the sales crown around this time as well. And so what you're talking about is like 2010, you maybe had 6 cores with Westmere EP. And that's an Intel part, and that would have been like the X5670s or something like that. But by the time you got to 2012, you had Sandy Bridge, and that was an 8-core platform, but you also went from having 3 memory channels up to 4 memory channels. And so everybody was super excited about the fact that, you get more memory channels, more memory bandwidth, you get more cores. That was amazing, 33% more cores. And soon after Sandy Bridge, we got Ivy Bridge and added more cores, and then AMD really kind of fell off for a couple years until like 2017. But you're gonna see that over the years, we had a pretty just kind of standard march. It was pretty uncommon to see more than maybe a 50% jump in cores. And that 50% jump in cores was really on that scale of maybe, 8 cores, 6 cores, something like that. So it wasn't necessarily like a huge jump in core counts. And in fact, if you just kind of look at what the, growth rate or something like that is, or if you looked like going back 5 years prior, you might see something where you might get like, 2 to 3x as many cores of, an upgrade of like a 5-year-old server. And, that's pretty darn good in terms of, your socket year-over-year performance. But this new generation that's coming out in 22, guys, is going to completely change that. Now, technically, these CPUs have not launched, so we're going to just put estimated here because they can always change the SKUs and all that kind of stuff just because of when we're talking about this versus when the launches are. But with the Intel Sapphire Rapids generation, they're going to move to a chiplet architecture, and that chiplet architecture is going to move from 40 cores to, it looks like the top end folks are saying is going to be 56 cores. Now, I will say that the Sapphire Rapids chip will have more hardware acceleration for things like cryptography, compression, all that kind of fun stuff. So they are going to definitely be working on those kind of hardware accelerators, and they'll have AI extensions and stuff like that to really accelerate a whole bunch of different workloads. So it's not just the core performance, also the performance of the entire chip with all these accelerators. So that is what it is. But the AMD guys, they are actually saying, hey, we're going to have a lot more cores, and their Genoa platform is going to have 96 cores. Just giving you some sense of scale, today's biggest processors that you can go buy would be something like a 64-core AMD EPYC Milan CPU or a 40-core Intel Ice Lake generation CPU. So we're not just talking about like a 33% jump in terms of core counts. We're talking about somewhere between a 40 to 50% jump in core counts just this year. And what you'll also see is that if you were to look back into like that Sandy Bridge generation and around there, you did have desktop processors that were 4 cores. So a 4-core processor versus, on your desktop versus an 8-core processor in your server didn't really seem like that big of a gap. But nowadays, just think about, you'll have a, say, 16-core processor in your desktop, but then you'll have a 96-core processor in your server, and you start to see that gap just become huge. But there's even more to this than just that chart. Now, what we do know is that next year, in 2023, we'll have AMD Bergamo. And the Bergamo is really a chip that's designed for cloud providers and really to provide more cores in the same socket as the Genoa part, and that will be up to 128 cores. And you may think that having 128 cores per socket or per CPU is absolutely crazy, and it definitely feels that way, but I will tell you that this is an Ampere Ultra Max, which is an ARM CPU that is kind of like the next generation beyond what you see Microsoft Azure just deployed like last week or 2 weeks ago. You also see that Google Cloud, Oracle Cloud, they're all using this Ampere Ultra Max and a couple of others. So this is like the hot ARM processor if you're not AWS at this point. And this has 128 cores, but they're about more equivalent to the cores, like maybe 2 of these cores is about equivalent to an AMD Milan core, but still, just this is a 128 core processor, and I have it sitting here in my hand. And 128 cores may seem like a lot today, and the next generation Ampere parts are of course going to be looking at having higher core counts as well. But the fact of the matter is, when you look at this curve, what you're seeing is that 100 cores, yeah, we're going to hit that next year. But it's not going to be that long until we have 200 plus or 300 plus cores per socket. And I don't mean that's like 5 years away. I mean that's like maybe 3 years away. And by having more cores per socket, you get really awesome benefits in terms of consolidation in the data center. But you also get a whole bunch of very big problems, especially, if you're in the business of monitoring hardware, and monitoring applications and stuff. Well, that presents a whole bunch of different problems when all of a sudden you can have much higher consolidation ratios. You can have many more things running on a single system. Some people like to say more cores, more problems, but I like to say that there are more OFGs or opportunities for greatness, because there's a lot of really really cool innovation happening around what has to happen to support these super high multi-hundred core CPUs that are coming. So the first one is a theme that we talked about last year, but there is going to have to be some kind of liquid cooling. Now, there's a whole bunch of different kinds of liquid cooling, but the two main ones or three main ones that people are really looking at are really the liquid cooling, which is direct to chip liquid cooling, which is very similar to what you see in like a high-end desktop or something like that. You see a lot of video game, guys that do video games and stuff like that. They will use something that's similar, but kind of scaled up into a something that you could use at a supercomputer scale, and that's really the direct to chip liquid cooling. The world's first public exascale computer that is actually, or supercomputer that's actually that can do an exaflop. That one you can actually see me holding one of the nodes up in Canada, but that one is actually using this direct to chip liquid cooling. We have some videos kind of going through how all that works. If you really want to go check that out, definitely we have information that we can get you. But the fact of the matter is that these chips are going to use more power. We're going to start seeing the top end CPUs aren't going to use like 200 to 300 watts. They're going to be in the 300 watt to 400 watt per CPU range. Of course, remember there's going to be 2 of them per server, and in modern systems, it's not uncommon to see 8 of these CPUs in just 2U or 4 of these CPUs per U. So adding another 100 watts or so per is actually becomes a big deal just for cooling. The other side to it though is that accelerators like GPUs in the data center are super popular, and those things are also raising in terms of their TDP. The photo of me with the NVIDIA H100, which is their next gen data center GPU that we're going to start to hear about more in Q4, maybe late Q3, that actually can go up to 700 watts. Well, at least 700 watts is what the spec is. And so you can see the tray that has 8 of these GPUs and they're 700 watts each, which just basically means that, just that tray alone, without the rest of the system that's around it, you can't even power that out of a standard North American rack. And so people are using liquid cooling because it's more efficient, less costly, and folks I think are becoming a little bit more comfortable with that has to happen. Now there's another technology which is immersion cooling, and that one there's really single phase and dual phase immersion cooling, and the whole idea there is that you take the entire server node, you pull out all the fans, and you go throw it into a vat of non-conductive liquid, and that non-conductive liquid removes the heat from the hot components, and then you have some way to extract that heat, and that's how it works. So the immersion cooling is you're dunking your server, and then the direct-to-chip liquid cooling, which is really popular right now, that one is really kind of similar to what a gaming PC would use, and is really just kind of piping liquid through a cold plate that sits on a CPU. But power and cooling are a huge deal in the data center, and anybody that's in the data center industry right now that's deploying high-end systems, especially for AI or other high-performance computing applications, those folks are definitely looking at liquid cooling right now because it's a big, big deal. Now, the next one I want to talk about is the rise of the DPU. Now, we have stuff on what is a DPU, what's the difference between a DPU and a NIC, and all that kind of stuff on the STH main site. We also have it on our YouTube channel. But what I really want to get to on this is the big development recently is that VMware vSphere 8 is going to support DPUs. And if you want to know what a DPU is, another way to think about it is it's AWS Nitro, and AWS's Nitro cards and ecosystem that folks are trying to bring that to the non-AWS cloud. So whether that's the VMware ecosystem, we have a picture of Mount Evans here, which is the Intel solution for Google's cloud. The idea is that the rest of the industry is really trying to play catch up with AWS and build this type of infrastructure. So this is an NVIDIA Mellanox Bluefield 2 DPU. And one of the big things here is that this actually has an ARM CPU complex, and it's an entire system that runs Ubuntu directly on the NIC. And for VMware, they're going to run vSphere directly on this. And what that allows you to do is separate the infrastructure layer with basically by having your infrastructure provider own the operating system and what goes on this DPU. And then the application layer, which is, everybody running untrusted applications on machine. So this is a fundamental shift in how we operate servers going forward, because it's always been that, you have a server and then that server has maybe a baseboard management controller, but really you're running your hypervisor and all that kind of stuff. You're running directly on the server itself. Also, if you're going to have things like you're going to encrypt your network traffic, you have VXLAN going, you have, whatever you have, whether it's even block storage, you bring block storage into the server, all of that stuff typically runs on the server itself. A security challenge, right? If you have folks that are also running their applications that may not be trusted on that server. So the idea with the DPU is really not just the fact that it's cool, they're high speed and all that kind of stuff, but it's really the fact that you are separating that infrastructure provider layer with the application layer. AMD just spent over $1 billion on Pensando to have a DPU solution. Intel has a number of different solutions. We've looked at a couple of them, and NVIDIA is aggressively making these these DPUs. There are other startups that are doing this as well. And one of the big reasons is that networking has to get faster, because if you have a server that now has hundreds of cores in it, of course you need to have faster networking, especially if you're also going to deliver things like storage remotely and stuff like that. I mean, you just need it more networking bandwidth because these servers are getting so much bigger. So the rise of the DPU is certainly a storyline that we expect to be all over in 2023. And so if you haven't heard of it, it's definitely worth reading up on, because the DPU thing is absolutely super cool and they're a ton of fun, and you can actually get them and play with them and do a lot of really cool things. We've done a couple really just kind of fun demos on the STH main site as well. So DPU, big area. Now, I've previously talked about CXL. In fact, I have this little thing called the taco primer to CXL. And recently at trade shows, I had people actually, oh, you're the taco guy, because I think so many people have seen either the article or the video on that one. But CXL stands for Compute Express Link, and it's basically the industry's way to go and change the entire infrastructure of how servers are built. What it allows you to do is not just do block storage and stuff like that, but you can also do direct load stores like you would to memory, but instead of having it like be memory that you go put next to your CPU, you can go put it basically off of the same type of lanes that are like PCIe Gen 5 lanes. So using our DPU as an example here, imagine instead of having like a network card, you just put RAM here, and then you had this just giant RAM pool that was available to your server. Some of the early use cases of that are going to be going between like GPUs and other AI accelerators and stuff like that, and main memory, and being able to do direct load stores between the two. And that's really the main use case for CXL1. And those CXL1 or 1.1 devices are going to be hitting the market in 2022. So this generation with Sapphire Rapids and Genoa, we expect to see CXL. But starting in late 2023, or most likely in 2024, you're going to start seeing things like CXL switches. And CXL switches are super exciting, because those are the components that allow you to go start doing pooling and have a whole bunch of devices. And you basically, it's like having a network switch where you have a network switch and you have a whole bunch of devices plugged in, they can all access each other. So imagine being able to do that with things like memory. This is a huge, huge feature for folks, and that's not really that far away, right? It's probably about a year and a half, 2 years away. The big one that was just announced though is CXL 3.0, and CXL 3.0 allows you to not just have that kind of switching, but allows you to have multi-level switching, or realistically allows you to build a fabric with all of this stuff. And so that CXL 3.0 generation, that's really where we are going to start seeing the disaggregated infrastructure that maybe probably folks have probably heard about because it's been around for so long, people have been talking about it for so long. But that's really where you're going to have, here's a shelf of compute. Here's a shelf where it's just memory. Here's another shelf where maybe it's storage, or maybe GPUs and accelerators, and just putting things together in a system in a disaggregated fashion. So that way, you don't necessarily have to upgrade your CPUs at the same time that you upgrade your memory, or upgrade your, GPUs or your storage or whatever that is. You can go and do those in a piecemeal fashion. You can upgrade them arbitrarily, and that's really the power of CXL3. And that's why, the hyperscale guys are super excited, because it saves a ton of money if you can do that with how much you're spending on memory. So CXL is going to be a huge deal in the industry, and we're going to start hearing that starting with this generation of CPUs that's going to launch later in 2022. Now, the other big one that we're really seeing in 2022 and into 2023 is the move to chiplets. Even Intel, with its monolithic Ice Lake core, where you just have one die and that's the die that's in your CPU, they're going to be moving to a chiplet-based architecture with Sapphire Rapids, and they're even doing extreme things. For example, Intel also has Ponte Vecchio, which has 47 different tiles that make up their data center or high performance computing GPU. Companies like Juniper are building their switch and router ASICs based on this now. There are new GPU manufacturers like Byron in China that's creating brand new, actually very competitive GPUs using chiplets. AMD and NVIDIA are still integrating HBM and large dies, but we're probably going to see a move on their GPUs to chiplets in the not too distant future. I would guess probably by the time we're in late 2023, we're going to start, at least if not seeing it, maybe hearing it. Something that we covered recently was how Tesla is building its Dojo supercomputer, and it's basically going and building it's basically taking a whole bunch of different packages and then repackaging them together to go build a brand new AI, supercomputer for its self-driving AI, training applications. So that's really cool. And then you're going to see this huge chip that's like literally the size, that's the biggest square you can cut out of a wafer, and that's the Cerberus Wafer Scale Engine 2. And so that is just a giant chip, and that's kind of going in the other direction of chiplets, but it's still very cool technology for an AI chip. It is by far the biggest one on the market today. But the big one is going to be UCIe And that's really what a lot of the cloud providers, but also a lot of the big chip manufacturers are making. And they're saying like, hey, we're gonna have this new standard, and that's gonna be an interoperability standard between different chiplets. The vision is that there's gonna be a chiplet marketplace. So that way, if you have an application, you can go pull different types of IP and different chiplets from different vendors, and you're able to go put them together and have them all talk the same thing, be able to integrate easily and create custom chips. That is a huge deal because how we've operated in the data center industry is basically like, you have an Intel Xeon part, and that Xeon part, if it's a V3, V4, if it's a Skylake generator, whatever kind of generation it is, it's pretty consistent actually between if you get a Dell server, Lenovo server, HPE server, Inspur, Supermicro, whatever kind it is, they're all pretty much the same. They're also pretty much the same when you go up to look at the cloud providers. They have pretty much the same chips realistically. But in the future, the idea is with UCIe, if you have enough scale, you can actually go create your own custom chips without having to go and build everything yourself. You can just go pick chiplets out of from different vendors, put them together, and have something that is more useful for whatever purpose you need. And what that may mean is that you have a different chip if you buy a Dell server versus if you buy an HPE server, and that may be a different chip than you would have if you go to a cloud provider. Now that's certainly a little ways off, but on the other hand, it's also something that is being enabled by a technology that is very, very close, and it's about to hit the market like very soon. Now, we are just before a new generation of processors, and that new generation of processors by both Intel and AMD, that is going to mean that we're going to have new servers and all kinds of really kind of fun stuff. We get to see really fun new technologies because, frankly, we haven't talked about a lot of the really cool things that are coming because there's stuff that we're just not allowed to talk about until they launch. But if you do want to learn more about hardware, well, why don't you check out ServeTheHome? You can find us at ServeTheHome.com. You can find us on Twitter at ServeTheHome, and then also on YouTube at ServeTheHome Video. Again, we're trying to get 100,000 subscribers by the end of the month, and we're not too far off. So with that, I just want to say thanks for watching and have an awesome day.
Come on.